this lesson, you will write an equation for a proportional relationship and write an equation for a non-proportional relationship. So just a quick reminder here, a proportional relationship is y equals kx, where this is our constant or our slope. So you will be able to use what you used on the last lesson here as well. So is this proportional? The equation I have is y equals 3x. Now you already know it's a yes because it's in the y equals kx equation, so you already know that it is. But just to prove that it is, when you graph this, it is going to go through origin. Remember how we graphed the other day? And then this is my slope. It's a rise 3, run 1. And so we are able then to say yes that it is proportional because it goes through origin. Right here it goes through origin. And I should connect this with a ruler and draw it. But it goes through origin and then it also has a slope. So just because it's given in this equation, you know that it is proportional. So you try the example in your notes. What you're going to also do today is look to see in a real world situation if something is proportional or not. Marcus is a personal trainer at a gym, and in addition to his salary, he receives a bonus for each client he sees. So for one extra client, he gets $45, 2 extra clients, $90, and so on and so forth. So when we graph this, we are only going to need quadrant 1 of the graph. If he sees 0 extra clients, what would his bonus pay be? 0, right? So that's origin. So we definitely have one clue that it might be proportional because it does go through origin. Now what we have to make sure it has is a slope, a constant addition, a constant subtraction, something like that. So if he has 1 client he sees, that's 45, 2 clients, that's 90, and as you graph it, you're going to see you have a ray that does go up. And if you will look, this is always a difference of 45. So what is the equation we can write? Y equals 45x, because this is rising 45 while it's running 1. And you can even use slope formula here too if you're not sure. You could take this y2 minus y1 over x2 minus x1, and you would still get 45 over 1. So if Marcus were to see 8 clients, what would his bonus pay be? Well, you could just plug an 8 in here and just do 45 times 8. And when you do that, you can see that he does make a total of $360. So I'm going to give you a real world situation in your notes for you to try, and you can do that at this time. The last thing that you're going to do is to look at graphs that are not proportional. See how this one does not go through origin? So this is not proportional. But I can still write an equation for it. And here's how. Whatever is happening at 0 is really important. Really, really important. And here's why. Whatever's happening at 0 is going to tell me what's being added or subtracted in this particular graph. So if you look at the 0, you see it's going through 6. 0 is going through 6. So that tells me that this is going to be a y equals something plus 6. Now we know that this is going to be an x. And that's just a given. We always have something that is being multiplied by x. What you already are kind of, I think, hopefully what you're kind of thinking is that it's a slope. Because y equals kx, which you've already worked with, a proportional relationship, this is our slope. And it's going to be the same in this case. Whatever number I put here has to be the slope of this graph. So let's just see what's going on here. This is jumping from a 6 to a 9, which is a rise of 3, and it's running 1. Rise 3, run 1 is a slope of 3. Now, if you wanted to make sure that this equation is right, you could plug in some of the points you see here. See how 2 is a 12? So you would say, okay, 2 times 3 is 6, 6 plus 6 is 12. Yep, this works because when I plug in a 2, I get out of 12. And then what we're going to do is write it in function notation. So f of x is equal to 3x plus 6. So that would be the equation for this graph. So I'll give you one to try in your notes. Give it a shot.